So what we have until now, I think, is we see that with all three tools you can use similar approaches. Take a little time to figure out what you're actually dealing with. Do you need to scan an entire drive, or do you need to scan an entire volume or lost volume? Or do you want the tools to scan the existing file system, or basically explore the existing file system? Or in case the file system is slightly damaged, do you want it to run a quick kind of scan? Do you want it to allow the time to detect the file system, and once it has found the start of it has detected the file system, tools can often go from there and pretty quickly reconstruct the file system. It's like untangling a piece of rope that is entirely in how do you call this? Which is basically one big knot. If you follow one end of the rope, you can sort of untie the whole thing. And this is how this sort of works with if you find one file system structure or some file system structure that is relatively close to the, say, root of the file system, then you can often go from there and reconstruct the rest of the file system. And so this is what we did with the scan, and we tried to avoid clutter. So we tried to tell the tools, okay, give us existing files, but do not worry about, for example, directories that are no longer connected to the file system because they were deleted at some point. Do not try finding raw files that may have been deleted sometimes a year ago, but they're still somewhere towards the end of the file system where relatively few writes take place. They may survive a long time. If you include those as well, if you try to recover those as well, you will recover more chaos only. And I'm assuming that if you deleted a file a year ago, you do not want it back right now from the partition you accidentally deleted. You want the current file system. So what else is there to tell? I wanted to talk briefly about this raw file system thing. Apart from them perhaps being useful as in themselves, because you recover those files that are no longer connected to a file system, which you may want to do under different circumstances. Apart from that, these raw files are also, if a file system is more severely damaged, useful for the tool itself to help reconstruct the file system. So under different circumstances, although you may not have an interest in the raw files, it may still be useful to select the option to scan for raw files. And I will try to quickly show you what I mean, but I'm going to first make sure it's starting fresh. And I'm using DMDE just because I think it's easiest to demonstrate what I mean using this tool, because it shows us the most information of all tools, I think. So I'm going to scan this region. I'm going to include raw files, and then I'm just going to click scan, and then we see the screen we saw before, and then we have to wait a little while again, and then we already see one difference, and that it is picking up these raw files. And for the rest, this kind of looks the same as with our previous scan. More raw files type are being added. It's basically just a partition I copied a bunch of raw files to, so that there was something in there we can try recover. Some music. Maybe add some music here. But now we see a difference. If you recall the last scan, we did not have this main result actually being there. And this main result actually being there now and not the last time is because I ticked the option to scan for raw files too. And this is how we can see that these raw files help the tool to be more confident about one of those 3 file systems it listed there. And it's even confident enough to tell us, okay, this is the file system you want to recover. And part of the confidence, for example, comes from the fact that it finds file system entries that claim a raw file to be somewhere on some location on the drive. But it can now cross-reference it with the raw files it found and say, okay, indeed there is a raw file there. So then the more file system entries I find that are, so to speak, backed up by raw scan results, the more confident I am about a certain set of file system parameters. For example, one thing the tool needs to do is determine a cluster size, for example, because file system entries point to a cluster number. And to go from a cluster number to the actual location on a drive, you have to know the cluster size, because I can point to cluster 100, but the actual location will be a lot different if we consider a cluster size of 4 sectors or a cluster size of 16 sectors. I'm just calling out numbers. This will make a difference. And so cross-referencing the raw results with the file system results makes the tool more confident. And so this is one difference we get from actually selecting the raw files, even if we're not interested in those raw files themselves. I can now open the file, the volume, and we'll see more differences. Did it do something wrong? Oh, it didn't click. So now we have basically the same list of files again. But what we do see is that if we compare to the previous scan, is that we now have those little green triangles here. I don't know what the word of that is. And basically this means that this file based on a file system entry is backed up by a raw file. And so this means that you can be more confident about this actually being a file you can recover, and after recovery you can open. if we would have file system entries that are not backed up by raw files, we would not have this little nice green triangle, which then tells us that we could recover the file, but we would basically be recovering a corrupt file. Now, the reason why I initially said, okay, raw files are just bringing chaos, is because people tend to review files and then find raw files here from which they cannot immediately tell, are these files I'm interested in? And are these duplicates or are these unique files? This is what often brings the confusion. And now again, the little triangles tell us that this is not only a raw file, but the little blue triangle tells us that this particular raw file has been found by the file system as well. So we're not interested in this file and recovering this file because we'd rather recover files from the file system, especially if we have a more complex directory structure and you want to recover files with original file names, including the original directory structure. The little thingy triangle tells us, okay, we do not need to recover this. On the other hand, the little triangle here gives us more confidence that the file that we will be recovering is actually intact. So this is one of the things, the benefits, so to speak, of including a scan for raw files, even if we do not want to recover those per se. I'm assuming that both disk drill and UFS use raw files in a similar fashion. I don't know, I'm not really sure, but I think that if we go here, no. No. No, I don't think we can actually now, in DMDE, if you, for example, would define your own raw file type because it's not included in the default list, you can also tell it to that the file signature is reliable enough to be using it, including it in file system reconstruction to, for example, calculate cluster size. And I thought there was a similar thing in I thought there was a similar thing here, but there isn't. But I'm still assuming that both DMDE and this drill must be using a similar trick to verify file system parameters and stuff. Yeah. One more thing about raw files is that suppose the files. Recently, I was recovering files from a memory card, and and nothing of the previous file system was intact, and so it could not be relied on to recover any kind of files. The file allocation tables were gone, the root folder was gone, everything was gone, and so then raw file recovery is basically the remaining option. So you try to find the start of a file based on certain byte patterns, and then you assume that it's the start of, for example, if we look at the Canon raw file, we can see that we can see the all start with similar bytes. So if we, for example, took those 4 bytes and we go scan the drive, then if we find this pattern of bytes, we could assume that we found the start of a Canon RAW file. Especially this CR is also something they all have in common. So we could even define a slightly more complex rule, because other Fujifilm, let's see, is this? That's not DMDE. Yeah, I think this is an entirely different file, and we see the same pattern. So it's not exclusive to Canon RAW files. But if we want to find Canon RAW files, we could expand our rule a little, and then if we find this and this, then we could say, okay, then we found the start of a Canon RAW file. And so this is how basically we find start a file. If we just keep scanning until we find the next file, we might have recovered a Canon RAW file. This is basically how RAW scans work. However, in this other scenario I talked about, the memory card, it was not about Canon RAW files, it was about video files. And I just want to argue that one RAW scan is not the other RAW scan. I didn't try this drive with disk drill. I could do that, but I'm not sure if I can do it without showing customer data. Maybe I'll do it. Maybe I'll pause in a minute and set it up. But one RAW scan is not the other RAW scan. So the memory card I'm talking about concerned MP4 files, and all MP4 files I recovered with DMDE were corrupt. And on the other hand, the same thing done with UFS. A good portion of the files was actually playable and complete and all that. And so between RAW scans and between RAW scan algorithms, there can be differences as well. In this particular case, for example, this was a Sony camera. I don't remember the exact model, but I used a disk editor to find out why UFS was recovering them and DMDE was not. And so it turned out that the Sony camera, because this was repeated in every video file, the Sony camera opens the video file, creates a header, creates the start of an MDAT atom, which is where it will be storing the actual raw video data. But as soon as it created that, rather than start filling it with video data, it's created a little JPEG, presumably to have a little preview to show on the camera display, for example. And then as soon as it created the JPEG, it saved that file, and then it opened the MP4 file again and started adding video data. DMDE kind of logically then detected the start of an MP4 file, and quite soon after that it detected the start of a JPEG file. So it at that point assumed the end of the MP4 file was reached and closed it. So basically I ended up with a bunch of tiny MP4 files. The same file was recovered intact using UFS. So then I can only assume that UFS is a bit more intelligent when it comes to MP4 files in this case. It somehow came to the conclusion the JPEG file did not mean the MP4 file had ended already. So it just created an extra entry for the JPEG file, handled that, and then assumed that as soon as the JPEG file ended, the MP4 file would be continuing, something like that, because the recovered files had no trace of this little JPEG section inside the file. It was not part of the MP4 file. So if you try to recover files with one tool and it does not recover them, it does not automatically mean another tool will not be able to recover these files either. So this is something to keep in mind. I will. Oh, the prices, yeah. So if we look at the prices for these 3 tools, including VAT in my case, the raw price for disk drill, 1-year license, I assume, because I didn't tick the option for a lifetime license, including VAT, is €101 and 84 something for is the raw naked price. DMDE 1-year license, €16, including VAT. And UFS, the naked price is $59.95, and including VAT is $72. So that's another thing to consider, of course. The price must be right. Let me see if I can set up this Sony. So I have set up this scenario, and I'm going to pause it again because scanning the whole thing is going to take time. But this is this is a disk image of the memory card from the Sony camera I talked about earlier, and I will scan the same image with both tools, not at the same time, because that's not. So I'm going to scan and then come back. So I have let DMDE scan 40% of the drive, and then we have reconstructed. So these are raw files, a bunch of them. I'm gonna let UFS do the same thing. Interrupted does not mean that I've interrupted the scan of this particular file. It cannot give us a estimation of the quality of the file because we interrupted the scan. This is what this interrupted means. Reviewing found data is more intuitive in disk drill than it is in UFS. I have to click here. No. Do we have files that are similar? This one, for example, is similar size as this one. Well, this is what I mean, basically. I do not even have to recover the whole thing. can sort of tell you that because I've recovered these files previously using UFS, so I know they work. I know they basically work as soon as it can show us a preview, because it generates the preview from the actual data, the actual video data, where we see that in this drill we have nothing. This file 128. I'm assuming this will correspond with this file. But so again, it does not play in. And for fun, I can recover one to prove you it's really working. 00882100. And I may need to blur it when I play it. There it is. Oh, I hate it when it. Okay, so this is enough. It plays. It plays the entire file. I can only assume that it will not work in. Oh. I don't have a license for disk drill, so I cannot test, recover it, and play it. But I'm assuming since any preview is absent, it will not be able to. Can I view in hex? How does this work in this? View as hex? Can I do this? Oh, here, hex view. Maybe I can guesstimate by what I see if. A bunch of zeros. Can I view as hex? We can compare. Oh my god, this is so slow. Page down. So a bunch of zeros seems to be, yeah, there was some data. Can I tell what it is? Oh, this is where the MDAT starts. No, I don't want to select it. I want to. Why is it doing this? I cannot use page down. Oh, fucking annoying. I can use the arrow, the down arrow, but. Is what I was saying corrected? Oh no, of course not. So, why doesn't it work? It's really annoying, this drill. things like hex views and stuff. Some tools just add it because it looks professional or something, but they forget that people are actually using them. And so this looks like something that is in here because it looks nice. This will take ages. And this doesn't work either. I have to click, I cannot, I can keep it pressed. Hello, move. Oh. 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 Can I search in it? Oh my god, this is unusable. Yay, I found something unusable in this grill. No, this is not what I mean, but here we go. It is really annoying. Huh? I don't understand what is happening. Oh my god, can I type in an address? No, I cannot. So what I'm trying to do here is if I can see here if the problem, oh my god, now well this is unusual. It's really too fucking annoying. Oh my god. Oh. Yay, I think. Ah, here we see it. Here we can see it. Why did it move away here? So here we can see the big difference in the raw carving algorithm. Both tools find the MP4 file. That's more up there, and then I talked about the MDET atom, which we find here, and I told you that the Sony camera creates the MDET atom, but then closes the file, creates a JPEG file, closes the JPEG file, and then reopens the MP4 file. And we see this is why the raw scan of this grill fails. We see the same MDAT atom, and then we see the header of the JPEG file. So it includes the JPEG in its recovered MP4 file, and this is why it doesn't play. And so this is where we can see that one raw scan is not the other raw scan. There can be differences in approach, more advanced algorithms that can make the difference between a raw file being recovered or not being recovered. This is going to be a very long video. I'm going to end it here and see you later, alligator.